Okay, this is Geo37, equations of lines in a coordinate plane. Okay, so all of this is sort of a review. You guys have seen this a few times already. So, a slope. In a coordinate plane, a slope is basically the rate of change. It's essentially the rate of change. And the rate of change is just a comparison of two things. In this case, we're by division, and what we're comparing is the change of the y. And I'm putting a triangle for change over the change of x. So the y would be the rise, the x would be the run. And a slope just deciphers what changes as you go up or down, what changes as you go left or right. That is our slope. How does the rise or the y change over the x or the run? And we usually give it a symbol, and it's the lowercase m. This means slope. And the equation for slope, you need two ordered pairs. If you have an x, we call it an x1. We have a y1, that just means the first x and the first y. And if we have an x2 and a y2, which just means the second x and the second y, the slope equation is y2 minus y1 over x2 minus x1. That is our slope equation. There's two ways that you can get the slope. You can use a graph to find the slope, or you can use the ordered pair from the graph to find the slope. So one of the questions is, what's the slope of line A? This line here is line A. I'm looking for 2 points. One of my points is 5 and 7, and my other point here is 2 and 3. Let's call this guy over here my x2 and my y2. Let's call this guy over here my x1 and my y1. Remember, slope is y2 minus y1, rise over run, x2 minus x1. So here I have 7 minus 3 over 5 minus 2. That gives me 4 over 3 positive. So this would be my slope. So what does that mean? If I go up 4, 1, 2, 3, 4, and over right to the 3, 1, 2, 3, boom. That is my slope. That's what that means. If I go to the right, 4, 1, 2, 3, 4. I'm sorry, to the right 3. 1, 2, 3, and up 4, 1, 2, 3, 4. Then I get to the next point. That is my slope for A. For B, they give me what is the slope of line C. Here's line C right here. And line C is a unique case. And show it right now. We have coordinates 1 and 7. You have coordinates 5 and 7. So again, rise over run. We'll call these my 1s and these my 2s. 7 minus 7 over 5 minus 1, which gives me 0 over 4, which gives me 0. So my slope would be 0, meaning it doesn't go up as it goes to the right. 1, 2, 3, 4. Distance of 4. Notice that when a slope is 0, you get a horizontal line. Okay. There are 4 types of slopes. Here we have a positive slope. And a positive slope means a couple of things. This is going from left to right. As we go from left to right, the slope is increasing. It's going up. The line is increasing as you go from left to right. This is called a positive slope. We also have a negative slope. A negative slope is as you go from left to right, your line is decreasing. It's going in the downward direction. So if we have a positive slope, we'll have something like, just like we had before, the 4/3. It's a positive number. If we had a negative slope, it would be like negative 4/3 because we're now going in the downward direction. This is all going from left to right. It's going to look different if we go from right to left. We'll talk about that later in life, not today. Then we have something called a zero slope. And when you have a zero slope, that means your numerator is 0. Your numerator is 0. Actually, I'll just say 3 to be consistent with all that. Your numerator is 0, which means you have a slope of 0. Zero slope. And when you have a 0 slope, you have a horizontal line. And then you have a undefined slope. Undefined slope. And when you have an undefined slope, your denominator is 0. Your denominator is 0. Oops. But here's the rub. You can't divide by 0. So it doesn't really exist. It doesn't happen. That's why it's called as undefined. There's no such thing as a slope with a 0 in the denominator. And when we get those situations where you have an undefined slope, when you have an undefined slope, you get a vertical line. You get a vertical line. Positive slope, you go in the upward direction from left to right. Negative slope, you go in the downward direction from left to right. Zero slope, you have 0 in the numerator. Hence, you got a slope of 0, you have a horizontal line. Undefined slope, you get a slope of 0 in the denominator, which makes your slope undefined or not exist, and you get a vertical line. There are 2 forms of, or there's many forms, but 2 main forms of linear equations. We have something called slope-intercept form, which is the one that you guys were using a lot. And it consists of y equals mx plus b. And the reason why it's called slope-intercept because it consists of the slope and it consists of the y-intercept. And if you recall, the y-intercept is y when x is 0. Y when x is 0, meaning it crosses at the y-axis. So if we look at these examples here, right here would be the y-intercept, right here would be the y-intercept, and right here would be the y-intercept. So y when x is 0, where it crosses the y-axis, is the y-intercept. Then the other version is something called point-slope form. And point-slope form is in the form of y minus y1 equals m times x minus x1, where you have the slope. Here you have the y coordinate. This is for a given x1 and y1. You have the y coordinate. And you have the x coordinate. That's why we call it point slope. You got a point, and which is the x and the y, and the slope. The other one we call slope intercept because you have a slope and you have an intercept. And those are the two forms of linear equations in this section. Graphing one of these, it's really easy to graph these. Forms of lines. Here they give me an equation in the form of y equals 2/3 x plus 1. So since I have the slope and I have the y-intercept, remember the y-intercept is y when x is 0, I have a point, I have a starting point. So remember that 2 would be my rise and 3 would be my run. Since they're both positive, that means I'm going to go up 2 and I'm going to go to the right 3. Since they're both positive, I'm going to go up 2 and I'm going to go to the right 3. So if I start at my starting point, which is my y-intercept, that would be 0, 1. Since my slope is 2/3, I'm going to go up 2, boom, boom, and to the right 3, boom, boom, boom. Connect the dots, and I have enough information for my line. So using the graph in slope-intercept form, I can find the initial point. Since I already have the slope, I can utilize the slope in order to put the two lines together and connect and graph my line. That's using y-intercept form. We can also do this using point-slope form. In this case, our equation is y minus 3 equals -2 times x plus 3. Remember, the form of this equation is y minus y1 equals m times x minus x1. Since we have a positive here, we can actually rename this thing right here, because it has to be in the form of x minus x1. So we're going to have, instead of x plus 3, x minus -3. We can rename this. That helps us out. So we have our point and we have our slope. We have a slope of -2 over 3. Remember, we have rise over run. So our rise is -2. That means that we're going down 2. Our run, this is all going from left to right, is 3. Since our run is 3, we're going to go to the right 3 as we go from left to right. That's our slope. We have our point, right? We have y minus y1, so our y coordinate is going to be 3. So this would be our point. And it's x minus -3, so our x coordinate, or my x, is -3. So my coordinate is -3, 3, and it's going to be there from which I start. So I go 1, 2, 3, 1, 2, 3. Here's my first point, -3, 3. And remember, I'm going down 2, 1, 2. I'm going to the right. What's my step? Oh, I'm sorry. Slope is 2 over 1. I'm going to the one right. To the right one. Okay, so down 2 and then to the right one time. So 1, 2, 1. Put my points together, connect the dots, and then form my line. Okay. They want me to graph those things. I can sort of make up a graphy graph. Let's make up a graphy graph. Why everything got to be at 4? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. My first equation is y equals 3x minus 4. This is in y intercept form. We have a slope of 3. So we can rename this as 3 over 1. So my rise is up 3. And my run is to the right 1. My y-intercept, remember, is y when x is 0. So I have y, and I have, since it's a minus 4, it's -4. Since this is a minus 4, it's -4. So it's 0, -4. So my first slope is going to be right, my first point is going to be right here. So this would be 0, -4. I'm going up 3 and to the right 1. So 1, 2, 3, 1. So I have that guy right here. And then connect the dots. That would be my first line. Okay, so that's A. I'll write right down here. Alright, so for B, have y minus 2 equal negative 1/3 x minus 4. So I have my point, I have my x, which is 4. Actually, no, let's do the slope. Slope is negative 1/3. Since the rise is negative 1, that means I'm going down. And the run is 3, I'm going to the right. By 3. So down 1, to the right 3. My point is going to be x minus 4, so that's going to be 4. Y minus 2, so that's going to be 2. So 4 and 2, so 1, 2, 3, 4, 1, 2, so it's right here. I'm going to go down 1, 1, and to the right 3, 1, 2, 3. Can't connect the dots, but it looks something like that. Since this is a negative slope, as I go from left to right, I'm going in a negative direction. That makes me feel confident. Since this is a positive slope, as I go from left to right, I'm going in a positive direction. I feel good about that. Writing equations of lines. It says, what is the equation of a line with a slope of negative 1/2 and a y-intercept of 2? So remember, slope-intercept form is in the form of y equals mx plus b. If I have a slope of negative 1/2 and I have a y-intercept of 2, then I can plug it in. So my equation is going to be y equals negative 1/2 x plus 2. That would be my equation. They give me another scenario where I have an equation where it gives me a point and a slope. So I know I'm using point slope form. So it's going to be y minus y1 equals m times x minus x1, where my point is negative 1 for my x and 4 for my y, and my slope is negative 3. So I'm going to plug that in. So y minus 4 equals negative 3 times x minus negative 1, and that turns into y minus 4 equals negative 3 x plus 1, and that is my equation when I'm given those two scenarios. Okay, and in here, writing equations when you're given 2 points. Okay, so the first part here in part A, they want me to put this first in point slope form, then into y-intercept form. Slope-intercept form, so the first part is going to be point slope. That's what they want us to put in first. First step, we have points negative 2 and negative 1 and 3 and 5. First step, find the slope. We know that slope is equal to y2 minus y1, x2 minus x1. In this case, we'll call these my 2's and these my 1's. 5 minus negative 1 over 3 minus negative 2. And that gives me, that's 5 plus, that's 6 over 5. That's my slope. Once I find my slope, I can choose either point. It doesn't matter which one. It doesn't matter which one at all. I'll choose this because it's all positive. And I'm going to put it in point slope form. And remember, point slope form is in y minus y1 equals m times x minus x1. So we'll use these guys here. So I'll say y minus 5 equals 6 over 5 x minus 3. So if I use that point, it would be my equation. I can have another version, and I can also use the other point, and I can say, if I wanted to, y plus 1 equals 6 fifths x plus 2. And this would be equally valid. These two would be the same slope. They want me to put this in slope-intercept form. Since I already have it in, I already have it here, I can just easily turn this into slope-intercept minus 5, 6 fifths x. I'm sure I did this right. 5 minus 1, 3 minus negative 2. Yep. First thing I'm going to do is I'm going to use the distributive property and expand that out. And I get y minus 5 equals 6 fifths x minus 18 fifths. And then I'm going to add 5/3 to both sides. Or I'm going to add 5 to both sides. I'll add, instead of 5, I'm going to call it 25 over 5. So that I can deal with the equation. So it's going to be y equals 6 fifths x, negative 18 plus 25. That's 7. So plus 7 fifths. And that's my equation in slope-intercept form. So you can put it in point-slope form, distribute the slope using the distributive property, and then add or subtract the y-coordinate on both sides, and that will get you your slope-intercept. Okay. Equations of horizontal and vertical lines. So they give me a point 4 and negative 3. If they ask me what the horizontal line is, I look at the y-coordinate, because horizontal is when the y is the same across the board. And since my y-coordinate in this case is negative 3 and I'm told that it's horizontal, I say y equals negative 3. These are for horizontal lines. If I had a vertical line, I look at the x-coordinate and I would say x equals 4, and that would be for vertical lines. No point slope form, no slope intercept form, it's just y equals for horizontal. whatever the y coordinate is, and x equals for vertical, whatever the x coordinate is. And that is that section. Hope you have a great rest of your day.